All right, guys, let's see a little bit of the details on the power supply of my project. This is the Arduino HMI with an A3CS board in here. And I put a lot of effort to understand the power supply because it's the power supply that give power to the amplifier. And I would like to see how clean it is. From this external switch mode power supply, which is very Chinese. The name is Yuan. Adapter power is regulated with a maximum input or output of about 36.7 volts. That is DC, and that is what I'm monitoring right now. Let me explain a little by little or step by step. So this is a 220 volts output of maximum 36.7 volt DC, which is the input to my amplifier. This is gonna be a Class D amplifier from purePath Texas solution, a Class D, what we call is the Ultra HD. And before I'm going to install this one, this is a board that I bought from Taobao, and Taobao is the e-commerce in China, the popular e-commerce in China. Before I'm going to install it, I need to be very careful on the power supply. Again, the power supply is the source of power. If you input dirty, it will going to comes out dirty as well on the speakers, and especially that I'm using a digital bit stream in here using the Arduino Uno R3. That the bit stream is also going to impure the AC signal. Bit streams, because I'm going to make use of the I2C squared bit stream or the UART protocol somewhere in here. One, I'm going to make use of the LCD in here, which is not yet, and that is the one which is I already manually open the LCD. That's going to be another project, but this one is just a demonstration. So let's go back to the power supply. So I have 36 volts input. That is the LM2596, which will going to step down a DC-DC step down to about 6 volts. And what I'm reading in here is 5.5 volts. This is so because there is a blocking diode in there. I would say split diode. One diode is for the A3CS shield, powering the A3CS shield. Another diode is for the Arduino Uno R3. So we got 6 volts minus about 0.5 volts. We got 5.5. That is a real world. And what I can see in here on the oscilloscope using the OSC 4828, it's a virtual instrument. I would say a virtual oscilloscope from Lotto company. And I can see that the output is basically 0 hertz. There is no frequency. That is okay for DC. I mean, that is a requirement for DC. And the output is 5.7 volts. And oh, this is a touch screen, by the way, so it screw up a little bit when I touch it. I don't want to touch that. So you can see all of these things. These are basically a kind of stray noise, whether this is from an RF signal, like from the cell site or whatever it is, because actually these are acting like an antenna right now from the outside surroundings with the cell sites and the phone and the Wi-Fi, whatever it is, and these are acting like an antenna. And you know the reason why I twist this wire in here, because it will going to offset those kinds of noises from the RF. And I can see that it is stable. This is the 5.7 volts. It's stable. I just can see kind of noise in here. I consider that kind of noise. Those kinds of noise basically is from maybe the cable in here, and like a noise in here. So if I'm going to remove the cable in here, let me just see that, and then it's pretty clean. All right, so that's how you're going to determine where is the problem, where is the noise. If I'm going to remove the cable from the oscilloscope in here, it's very clean right now, and we can see that there is no any stray noise right now. So if I'm going to put it back again, and there you go. So somewhere in here is causing the problem, which is on the system itself. I would say like that. Someone is acting like an antenna and pick up all of this kind of stray noise. That's the good stuff having an oscilloscope, because you can see what the voltmeter cannot see. Oops, it power off. Yes, the oscilloscope can see what the voltmeter cannot see. And the next thing for me now is to install this the shield, the A3CS shield, into the Arduino. The Arduino is over there at the bottom. I use this one as a kind of come on. The spin is preventing me from removing it. Yeah, this is a lot of scratch in there right now. So that's the Arduino Uno in there. So I'm confident right now that I can use it. Let me just put it. Did I put it right? No, I did not put it right. Let me put this one and the camera into standing position. Let me put it. Just want to make it sure that everything is okay. Um, okay, so there you go. There is no mechanical protection actually in putting the shield in the Arduino Uno, and that's pretty bad, because if you made a mistake, then the ground and the supply will go to another pins, and that's pretty dangerous. So when I make it sure that I really put that, let me take a look at it using my phone. Where is the flashlight in there? So the flashlight in there, and yes, I put it in the right on the right slot. So let me put once again the power supply, and let's see if there is any boom in there, smoke. Maybe this one in here. I think this video will gonna be no edit video, so this is real life. This is actually happening in your band's. I'm going to just observe that maybe 2 hours with the power on in there. And while I'm doing that, I'm start to do the casing of a class A power amplifier, making use of this one, wherein I have to make another class A power amplifier for my friends, using the engine for the Arduino HMI. And that's what I'm doing it right now, while I'm doing the soft test for 2 hours for the Arduino HMI and the power supply. I wanted to stress, guys, that power supply is very important. That is very important in a hybrid system, because if the power supply is dirty, then you will get dirty as well. There is no like a kind of filtering in there, and that's what I'm trying to observe in here. This is gonna be the external power supply, so I'm going to use that one instead of my bench power supply, because that's not the real thing. This one will be the real thing. So let it soak just for 2 hours, and in that 2 hours I should be able to finish the front panel of my class A power amplifier. That's gonna be the ACA, the engine from Nathan Winterkamp. That's it. All right, let's do that, and let's go for that though. It's the moment of truth for the TI Class D power amplifier. This is the TPA3255, and now it is driven by the Arduino HMI with the A3CS board. This is the A3CS board, and this is the TPA3255. And we have only one human machine interface right now, which is switch with an LED inside. Let's start with the AF generator. This is the AF generator set to 1 kilohertz at about certain amplitude, and that's inputted, is splitted into the left and the right channel, and it goes in here to this TPA3255 amplifier. That's again the TI Class D purePath. That is what we call it, the Ultra HT. And we get the output in here. We got the resistive load, 100 watt, 4 ohms. It's warm right now. And currently we have about 12 watt of power output. I'm monitoring that with the use of oscilloscope, and I'm using the virtual instrument from Lotto, the OSC482, and this is the capture of the signal. This is the left and this is the right, and 1 kilohertz at 7.7 voltage swing. That is 7.7 multiplied by 7.7 divided by 4 will give you roughly about maybe about 12 watts. And that's what I'm trying to soak test in here. And later on, once I'm satisfied with the performance of this, then I'm going to go into this third setup. This is the third setup. Let me get the lights in here. There you go. Never mind those, guys, never mind those. It's on the cleaning process. So this is the third setup that I have right now. The first setup's in here, the second setup's in there, and there is the third setup that I'm currently made it, assembled this rack, and I'm going to put in here the Class D power amplifier from TI. And what's about this rose? Because today is a celebration for finishing the phase 1 of the Arduino HMI, and we're going to go for a celebration. I got things in here. Oh, this is a schematic diagram, by the way, and this is me. This is my Nathan boy drawing during his like 1.5 years old. That's what he's drawing. You know what kind of drawing is that? I treasure that, you know. I treasure that because it's really, really fantastic. And what I have in here during the celebration, we got wine, we got sake, we got beer in here. We also have Corona in there. That's gonna be the kind of celebration. And one Dove chocolate in here. It's made in China. You can see that one. That's just something that I'm going to go for a celebration. And what do we have in here? I still have the Absolute vodka in here for my celebration later on. And beef, that's for my protein. And go back to the setup. Later on, I'm going to go for it. Go for a demonstration with these new speakers I got from Winner. That's the company who produces speaker. There you go. There you go. All right, that's awesome. Into my apartment. I don't know if this is published in YouTube. What's gonna be the effect and the quality of sound? That are green, red roses too. I watch them bloom. So let's get the vodka, ladies and gentlemen, and let's gonna celebrate. Vodka in there. What I can get in here, this is one for the cough syrup. I can put it right there, and then let's get something in the vodka. There you go. There you go. All right, one for my father, and we're gonna celebrate for finishing this project, the Arduino phase 1, and that's how it looks like, ladies and gentlemen. Cheers, 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 everyone who follow this project, the Arduino HMI. Cheers, everyone. Cheers. Continue the music. And even if you lose yourself and don't know
ocean.